What's about this? I thought it was just
We're just friends.
Oh.
We're just best friends. Only we can Shall I run it back?
All right, guys, both handouts you picked up today make up 72 together. Jonathan, I'm going to stop asking you to sit down and start counting you tardy. When the bell rings, you need to make your way to your seat.
Can I stick them together?
Yes, but don't do it right now. We need to get started. But yes, I would probably staple those together. Both those handouts make up 72. So we're going to move forward and talk about a little bit more with our limits. And I've got one practice one for you to do. But if you did not turn in 67 as I asked you to do at the end of last class and or for homework, or if you don't remember, I'm about to grade those in a minute, so they'll be late after that. If you need to double check it, do that quickly, please. Okay, so what have we done? Okay, so day one we talked about limits and what a limit looks like from a graph and or a table. Then day two we started talking about 0 over 0, that was called direct or indeterminate form, and we started talking about how to deal with that. Day one we did factoring only as a way to deal with that, and then last class we dealt with two other ways to deal with 0 over 0, which was conjugates and trig identities. Today we are going to move forward with one other way, and that's going to be complex fractions and how to reduce those so that we can do the same thing we've been doing. And then we'll practice these type of questions reading piecewise functions. So you guys have seen piecewise functions before, but oftentimes you're not quite able to read and process those the way you should be. So first couple questions, nothing's really changed. Direct substitution is always what you should start off with. Hope that you get a number, because if you do, then you're done. If you plug in direct substitution and you get some number other than 0 over 0, that makes the fraction undefined, which makes the limit not exist. Okay, so that's like the third time I've said that, but those are things that still apply today. So what's a little bit different here is now when we do direct substitution, we get 1/3 minus 1/3, which goes to 0, over 2 minus 2, which goes to 0. So this is what we've been calling indeterminate form. 0 over 0 can be anything. But the three tools I've given you up to this point don't help with this, or at least they don't help you at the start. Nothing factors, there's no square roots to do the conjugate trick, and there's no trig functions to do substitutions with trig identities. So we've got to do something different to make this look different, get something to cancel, and then finish with direct substitution. Now, the good/bad news is complex fractions show up in lots of math things. Complex fractions is not anything specific to limits. So I think generally you guys have seen these in Algebra 2, but you don't practice them much in Algebra 2. So our very first step is we need to know how to deal with this. We need to think about how to make this look different without changing its size. So what I would love to do is I would love to be able to multiply this by 3, because times 3 divided by 3 cancels out. But if you only do that, now it's a different question. to keep it mathematically equivalent, you have to multiply every term by 3. So if you want to multiply one thing by 3, everything gets multiplied by 3. Likewise, I can get rid of this smaller fraction by multiplying by x plus 1. X plus 1 divided by x plus 1 cancels out. Bless you. But if you multiply one of them by x plus 1, then they all get multiplied by x plus 1. So you can see it starts to get kind of messy, so you need to be extra careful. But when the dust settles, I'm left with a 3 times a 1, a negative 1 times an x plus 1. I'll just distribute that negative 1. And in my denominator, I now have a 3, an x minus 2, and an x plus 1. So really what I did is I multiplied the top and the bottom of this fraction by 3, and I distributed the 3 to the two terms. And then I multiplied the top and the bottom by x plus 1 and distributed to x plus 1. Since I'm multiplying the top and the bottom of this fraction by the same thing, it's like multiplying by 1. So we're not finished. Some questions are still going to take just another step or two. Some might take 4 or 5 steps. But it's not a complex fraction anymore. We don't have these smaller fractions within a bigger fraction. So again, multiply by all the smaller denominators to make those go away. Now, to finish this question, it's going to finish kind of how we've been doing. So you probably want to try to combine some like terms here. 3 minus 1 would be 2. Okay, and then I think we need this trick a couple times today, but this is also a fairly unusual trick, algebra trick. But I know something needs to cancel. Just like with factoring, just like with conjugates, just like with trig identities, something has to cancel before you expect direct substitution to work. This and this are almost the same. They have the exact opposite signs though. Negative x positive 2, positive x negative 2. So the algebra trick is you can factor out a negative, which switches both of those signs. So you can factor out a negative just like a GCF. Then these are exactly the same and they cancel. And now that something has canceled, direct substitution should work out just fine. So we've got a few questions on the notes today. The extra practice is going to be just on the piecewise functions. So we're going to do all the complex fractions today. And again, I'm not trying to be dismissive on the second half of the question, but from here to here to here, this is really what you've been doing for days, except for maybe the negative trick. I'm going to focus more on the first step, taking a complex fraction and making it not be a complex fraction. So basically saying the same exact things again with a different equation. Try direct substitution. We get 1/7 minus 1/7 over 7 minus 7. So we get 0 over 0. Only when you get 0 over 0 do you need to worry about doing more work. Factoring doesn't work. Conjugates don't help. And there's no trig functions to do a trig substitution. So the only other one we've talked about besides those three is dealing with complex fractions. So I would love to multiply this by 7 to make those cancel, but you can only multiply this by 7 if you're willing to multiply all of the terms by 7. I would love to multiply this one by x so that those cancel, but if I multiply one thing by x, everything has to get multiplied by x. Okay, and then see kind of where the dust settles here. I'm left with x times 1 plus 7 times 1 over a 7 times an x times a 7 plus x. So simply multiplying everything by 7 and x made all of the smaller denominators go away, so now it's no longer a complex fraction. Now you can try direct substitution here if you want to, but again I've not gotten anything to cancel yet, so I'm still going to get 0 over 0 if I try that. But x plus 7 and 7 plus x are the same thing. Addition is called commutative, which means the order that you add things doesn't matter. So you can let those two cancel, plug the negative 7 into what's left behind, and since my direct substitution is not giving me 0 over 0 anymore, I can assume that that is good and finished.
Why wouldn't it just be negative 49? Is that because you got negative 49 on the denominator?
I got negative 49. Well, how would you reduce 2 over 4?
1/2.
Okay, so when these cancel out,
Gotcha.
if everything in your numerator cancels out, there's still a 1 there. It doesn't become 0, or it doesn't just go away. Okay, so now my question is on number 5. If we did direct substitution 0 over 0, what is one thing that you think we should multiply by in question 5? You say h plus 3? Okay, so let's multiply everything by h plus 3. And the reason why you should want to do that is to make these cancel. Timesing by h plus 3 and dividing by h plus 3 cancel. One of the smaller denominators is going away. Okay, somebody else, what is something else we need to multiply by?
83.
Okay, don't worry about the negative, but just the 3. Times 3 divided by 3 cancels, but if you multiply one of these terms by 3, everything has to be multiplied by 3. Notice how messy your work can get, so try to be extra careful there. But after I did that, I'm left with 3 times h plus 2. I'll just go ahead and distribute that. I'm left with negative 2 times h plus 3. I will go ahead and distribute that. And nothing canceled in my denominator, so I had the h that I've had the whole time, the 3 that I multiplied everything by, and the h plus 3 that I multiplied everything by. Again, I'm not finished, but it's progress because it's not a complex fraction anymore. I don't have smaller fractions within my bigger fraction. So basically you just multiply by the least common denominator of the small denominators. Okay, and then to continue on, to finish it up the way we've been doing, I don't know, you could combine like terms here, 3h minus 2h plus 6 minus 6, and something has to cancel. In this case it would be h's. And as soon as something cancels, now direct substitution should work out fine. Everything in my numerator is gone, so that means it's a 1. And plugging 0 into the denominator, I end up with 3 times 3, which would be 9. As long as I don't have 0 over 0 in the end, we can assume that's our answer. If we get 0 over 0, we didn't really do enough. Okay, we got 2 more of these that we're going to look at today, and I will try to give you some more practice of this in the future. But again, this really only this first step that's kind of unique. And again, this is not really limit thing, it's a algebra thing. So knowing how to deal with complex fractions is good. Okay, looking at question 6, what is one thing we could multiply everything by to make some progress? Jackson, you answer since you're not paying attention.
We can multiply by 3/4.
You do not want to multiply by 3/4. That's not going to help. You need to pay attention. Put your phone up.
X squared.
Okay, multiplying everything by x squared cancels that part out, so that's helpful. Okay, there's one other thing we need to multiply everything by.
4.
Multiply by 4. And again, if you multiply one thing by 4, every term gets multiplied by 4. Try not to get lost in all of this mess. You're left with a 3 times a 4, a negative 3 times x squared, and a 4, an x squared, and an x minus 2. Multiplying every term by 4x squared gets it out of complex fraction form. Okay, but to finish off the question, we need something to cancel. So I don't know. I would probably try to make this look different. I know I could at least factor out a 3. And now that I've factored out a 3, I see I could also do the difference of two squares. Unfortunately, nothing's quite ready to cancel out. But like a couple questions ago, these two are very similar. Positive 2, negative x, positive x, negative 2. If these two are the exact same thing except all of the signs are different, you could factor a negative out of either one of these. So pull a negative out, which changes those signs. Now something cancels. Now direct substitution should work out just fine. So I won't even write this. Plug in 2 into here and plug in 2 into here. 4 would cancel out 4 and we'd end up with negative 3/4. Okay, any questions about any of those steps before we look at one more complex fraction? Again, I don't have a million of these for you today. I just giving you an introduction. Yeah.
How did you get 2 plus 2? Because why doesn't the negative go to that 2 plus x?
Here,
Yeah.
it did. I just plugged in 2 into it though. When I did direct substitution, 2 plus x became 2 plus 2.
But how come, like, when you took that negative 1 out, it only goes to the 2 minus x?
Yes.
Like,
Okay, so last one of these. Again, I will have you practice this again in the future, but again, the end of the questions are going to vary in difficulty and the amount of steps, but the first step is imperative. If you don't know how to make this not be a complex fraction, unfortunately it doesn't matter that you could finish the question on these type. So multiply everything by 9 to get one of the smaller denominators to go away. Multiply everything by 3 plus x squared to get the other small denominator to go away. See what you're left over with. 9 times 1. Make sure you pay attention to this sign. Minus negative 1 times 3 plus x all squared. And then my denominator had an x. I multiplied it by 9 and I multiplied it by 3 plus x squared. That's the most important step to me, at least for today. Now, somebody first period asked a really good question here. It may have been on a previous question, but it was the same type of thing. And their question was, well, can't you just get these two things to cancel out? This is a 3 plus x squared, and this is a 3 plus x squared. You have to be careful that you can cancel out factors. Factors are things being multiplied. 3 plus x squared in the denominator is a factor because it's being multiplied by x, it's being multiplied by 9. But this 3 plus x squared in the numerator is not a factor, it's a term. It's being added or subtracted to something else. To help you see that that matters, I could just make up a quick example with numbers here. This is supposed to be 10/9, that's the real answer. But if you let yourself cancel out terms, you might think that the answer is 1. 10/9 is not the same thing as 1. You cannot cancel out terms. You can only cancel out factors. So to finish up, yes?
Could you, maybe after this question, could you go back to number 6?
No, I'm done with 6. It's been up long enough. Okay, to finish this one, we need something to cancel out the right way. So we can FOIL this. So this would be like, and it's negative times all of it, so I need to make sure I distribute that negative. But 3 plus x times 3 plus x. So 3 times 3 would be 9, distribute the negative. 3 times x would be 3x. X times 3 would be 3x. That gives me 6x, distribute the negative. And then x times x would be x squared, distribute the negative. So I really just FOILed this and distributed the negative. So combine like terms. you could factor out an x. The x's cancel, and now that something's canceled, direct substitution should probably work out. Plug in 0 for x. And reduce your fraction. Again, I'm not going to take the time to do it because we've talked about that for like 3 days. But if you were concerned in your practice, or if it was a test and you had a calculator, you could graph this original function that we started off with and then look at the y value it approaches as x approaches 0 from the left and the right. It's going to be some unfamiliar decimal, but if you type in this fraction in your calculator, you should see it is a similar decimal. So, okay, again, that's the last complex fraction question to look at today. So, is there any questions you guys have about the start or I guess the end of this one? Okay, take 30 seconds. If you would like to jot yourself a note, if you think there's some sort of reminder that would help you out, then please do so. And I'll pause for a second before we go on to the next piece. Okay, the other thing I'd like you to practice pencil and paper today. The last, I guess you could call this new, but typically in higher mathematics you guys have seen piecewise functions before. They often get exposed to you in Algebra 2, but you guys are not very consistent in reading a piecewise function, and that's pretty important for calculus and for college algebra, no matter which one you're doing. I mean, I guess it doesn't help for AP Stat if you signed up for that next year, but so, for at least this one question, I need you to write out what our thought process should be. This is asking you to do the exact same thing we did on day 1 of limits, but instead of giving you a graph to look at, it's giving you a piecewise function to look at. So we're trying to extract the same information. So, if I would like to know the limit as x approaches 4 of this, at least mentally, and for this question I want you to write it down, mentally you need to think about what does it approach from the left and what does it approach from the right, and if those are the same, that's the answer to the question. If those are different, the answer is does not exist. So you've got to be hyper aware of these inequalities over here. They're telling you which one of these to plug it in. Some questions we're going to plug it into both. Some questions we're only going to plug it into one of them. It depends on what the number is. So if I would like to know as x approaches 4 from the left, you think about a number line. If you're to the left of 4, your number is slightly smaller than 4. This is saying when x is bigger than 4. So I would not plug it into the bottom, I would plug it into the top. This is saying when x is less than 4, which is what it's going to be if you're approaching from the left side. So if you plug 4 into that, you end up with 16, 2 to the 4th. But when you think about the right limit, if you think about a number line and you're to the right of 4, then it's a little bit bigger than 4. So for the right limit on this question, we should be plugging it into the bottom piece, because this is when x is bigger than 4. So we'd be left with 8 times the square root of 4, which would also be 16. If the limit from the left is 16 and the limit from the right is 16, then the limit is 16. Again, same thing we did on day 1, but you had a graph where you could just look at them instead of having to think about which part of the piecewise function to plug it into. So let me say that a couple more times, I think 2 more times on this page, and then there's like 2 on the next page I'd like to talk about together, and then you can try the rest on your own. Okay, if I want to know the left limit of this one, as x approaches pi from the left, should I plug pi into this top part of the piecewise function or the bottom part of the piecewise function?
The top.
The top, because when x is less than pi is what it's going to be if you're coming from the left side. So for the left limit, you plug that in, and you get an answer of -1. But from the right side, if you're coming from the right, x is a little bit bigger than pi, so you need to plug it into the one that says x is bigger than pi. So you should plug it into the bottom one. The sign of pi is 0. So what does that make our limit answer? Does not exist. If the question had been left only, it would be -1. If it had been right only, it would be 0. But since it wants both, we need to say does not exist. Okay, one more and then we can jump over to the next page. So before I tell you, again, you don't have to write all this stuff out to the side for every single question, but in your head you need to be thinking about what's the left limit and what's the right limit. So I want you to take 5 seconds, just before I say it out loud, think about x, as x approaches -2 from the left, which one of these two is saying that? Which one should it get plugged into? Okay, so from the left is when x would be slightly smaller than -2, so it should go into the top one. 5 times -2 is -10. The right one, x is going to be slightly bigger than -2 and it's getting closer to -2. So you would want to plug it in to where x is slightly bigger than -2. So you plug that in. You also get -10. If the left and the right limit are the same, if the question doesn't designate, then it's got to be both. And what it is what it is. Now, the reason why I want to do a couple more with you on the next page is these three are maybe not the best examples in the sense that well, I don't want you to fall into a trap. If you oversimplify this and say, oh, you just plug this into the top and the bottom and you get your answer. Plug it into the top and the bottom, you get your answer. Plug it into the top and the bottom, you get your answer. That's not always the way it works. It's just those three happen to be that way. So I would like you to see if you fall in those traps by trying 2 questions on this page before we go over them. But there is 3, they're not typos, but they're almost typos because I know this doesn't print off great. My copy looks fine, but then when I make a copy of my copy, your copy gets further off. So question 3, if you would, real quick. This is supposed to be as x approaches -1 from the left only. Number 4 is supposed to be x approaches 3 from the left only. And question 5 is -4 from the right only. I don't know if y'all can see that on your page, but 3 left only, 4 left only, 5 right only. The rest are, everything else printed off okay. So change that.
So you want us to try all 5?
No, I'm going to tell you which 2. I'm just making sure everyone's got that changed. The only 2 I want you to try to see if you fall into some very common traps would be question 2 and try question 3. So without me giving you any hint, to see what you'd come up with on 2 and 3, and we'll see how that goes. Then for the rest of class, I'll ask you to finish this up, check your answers online, make sure that you clear up any misconceptions you may have, and then I have 1 review assignment. It's 1 Khan Academy. It's a little bit longer than the ones last time. So last time I had you do 2. Today I'm only having you do 1, and it's over dealing with 0 over 0 with conjugates. So we practiced that last class, but I'm asking you to revisit that.
doing this? It's been loading since the beginning of class.
Okay.
Did you have to calculate or you haven't looked at it
So
yet?
we'll just keep trying. But in the future, don't wait until the start of class when I asked you to do it before class. The start of class is really supposed to be last second.
Yeah, I know I had it done, but I wouldn't.
I know, but I need you to turn it in.
It says it's turned in right now.
Okay, good. I'm just saying you don't need to wait till class starts to turn it in. Just like today, it's asking you to turn in number 70. If you don't do it, and then you don't do it for homework, and then you wait till next class, and then you have issues, the problem is you waited till the last second. Okay, so let's go ahead and do 3 first, and then let's go back to 2. So 3 is different than the 3 on the other pages because this one only wants the one from the left. So it forces you to think about, should I plug it in the top or the bottom or both? You have to be paying attention to what this is saying. If you only care about from the left, graphically on the left, that's when it's a little bit less than -1. So you should have plugged it into the top only. So that would be okay. Or you could write it like that if you prefer, if you remember that exponent rule. But that's what you needed for number 3.
Is that it? Is there anything else, I guess? Because they didn't give us the E or final answer.
Well, E is just a number. There's nothing else you can do with that. Okay, but understanding why I plugged it into the top instead of the bottom is imperative. It's all of this is telling you how to operate this piecewise function. You have to pay close attention to it. Question 2, I think, is the trickier one, but again, it kind of helps you figure out if you're just trying to just always do this step and this step and this step and get your answer. If it always worked out that way, I would present it to you that way. This one wanted you to find the limit as x approaches -3. Which one of these 2 parts of the piecewise function exists at x equals -3?
The top one.
The top. The bottom one has nothing to do with -3. It's nowhere near -3. That is just a distractor. This, it's always the top if x is less than -2, which would be the case if you're going to the left of -3 or to the right of -3. But if you plug the same number, -3, into the same thing, 2x plus 1, of course you're going to get the same number. So the bottom one does not make sense because the bottom part of that does not exist at -3. If you just tell yourself, plug it into both and get your answer from that, that's not always going to work. It worked on the 3 that we did on the other page. It's not going to work consistently though. You actually have to read the piecewise function. Okay, so again, these are fairly quick questions, so you shouldn't be spending too long on this, but it is important. Bless you. This is not a skill we get to practice a lot of, so I will try to give you some more practice again before we get to the quiz on it. But you need to put in your best effort on the few that you have left on this handout. Check the answers with what I have online. If you missed any, put some thought into that. Bless you. So that you can make sure that you are approaching those correctly. So do that first, please. Then I would recommend you spend 2 or 3 minutes looking at your 2 handouts from last class, because 73 is asking you to practice one of those. And some of you even did that early, which is great, but if you did it early, then I don't know, you'll have more downtime today, I guess. But asking you to practice indeterminate form of conjugates for 73, that's in Khan Academy, and turn in 1 assignment from last class. So I will leave that agenda up on the board so that you guys can make sure you don't miss any of that. But you've got the rest of class to finish that up and feel confident about that. And you've got about 55 minutes, so that should be plenty of time. Please let me know how I can help.
If you check with Khan Academy. That's from December 4th class. And this one is late, but this one.
You don't have them.
Can you refresh the page, maybe?
These are not something you turn in the Google Classroom. Not there.
I did them though on my computer.
Okay, then let
Can
me
I
see.
show you? Do you know which should be?
It should show up under your assignments. Most people click their name. Notifications. That little blue dot there shows that you have something. Are you logged in under your school email?
I believe so. Because I got them on my email and then I did them. Like, look, check this out.
I'll click on it in your email then.
Went this one, I clicked this one, and then I did it. Come on. Give it a second. Start. Let's limit using conjugates.
Okay, that's the one that's assigned today, so
Oh, it
unless
is?
you did that
So I don't
early.
think I did that one then. But let me go back. Between the assignments, I did this one. That's it. I got 100% on it. That's the limits from tables.
Okay, go up to. I need to figure out what's wrong so I can get them right in the future then.
Notifications. See, that's like 2 months ago. I can't scroll up anymore.
Yeah, I get that. I'm not sure. Okay, for now, just show me them.
Okay, I'll show you then.
So that was the limits from tables. I saw that you had that one.
Yes. Bag.
And I need to see one-sided limits from graphs. Do you have a different school email than you had at the beginning of the year? Because it pulls it automatically from Google Classroom. I don't do it, so it's... Okay.
Maybe I can check.
I can give you points for those. That would be 2 from last time. And then there's one from before that, which was limits from a table.
It's called limits from a table. So it wasn't in this. Was it before those two?
Yeah, it was the first one.
I remember doing that one. Wait. if
I'd
I go-
also just put Khan Academy in your search, and it would just show you Khan Academy.
What's this one?
emails.
This one's limits with conjugates.
That's today's.
Okay.
So
I think I did this one too.
there's
I'll
a
show
few
you this
people
one.
who did it early, but I don't think you remember.
Yeah, I did do this one.
Limits using conjugates. Okay. When did you do that one?
I did it during lunch. I did all 3 of these during lunch.
Okay, well, that's actually part of today's assignment, so you'll be
Okay.
finished earlier, but I don't have that in gradebook yet, so I can't put that down.
That's fine. And then I'm just gonna put in Khan Academy and see.
It would have been
This one,
about a
estimating
week ago.
limits was today. So it would have been like this one. You think?
Limit values from graph.
Okay, that's what I thought. All right. If I do this, if I show it to you, do I get half credit for it?
It's late.
Okay.
But what I would do, as there's probably going to be a few more Khan Academy in this section, so since it's not showing up to me well here during class, you might want to show me that you have it done so I can get it scored correctly.
Sounds good. I'll do that near first thing.
Okay, thank you. Okay, in case I forgot to say it, make sure you guys let me know if there's something I can help with. Call me over or bring it up here. But check the agenda to make sure that you're doing all the last couple things to finish up class today. It's a couple little things, but you also have a good chunk of time here. Just under 50 minutes still.
So, if the limits don't match, it does not exist. Right?
Well, it depends. If the question is left only, it would be this. If it's right only, it could be that. But if it doesn't say, that means these have to be the same for it to exist.
All right.
So you can just say D and E for does not exist.
I think the bottom. Number 7.
Number 6.
Okay.
Just a quick question for you.
Sure.
So, I know the 6 the positive 6 right here would include this one because it's 6 that's greater or equal to. What about this one right here? It doesn't specify if it's supposed to be greater
Well,
than or
if you
equal.
want the limit from the left, you need when x is slightly less than 6.
Mhm.
If you need the limit for the right, you need when it's slightly
Gotcha.
bigger than 6. And this one you need both. So you
Gotcha.
gotta plug it into both to make sure they're the same number.
Okay, but since this one doesn't, I guess if this was equal, would that make it different, or
Because
can you still plug it in with that?
You can still plug it in because you're to the left of it. You're not at x equals 6. You're slightly to the left of it.
Okay, gotcha.
Limits don't care what's happening at that exact time, just what it's approaching.
Okay, gotcha. Thanks.
Do you have like a full list?
little behind. A little behind on.
Watch the class recording.
Yes.